yeah, welcome everybody to this new episode of Fish and Chicks. Today we'll do sort of a chemistry special, so we'll talk about what to look out for, stuff that kills fish, stuff that makes plants happy, and how to test for this for different compounds and ions. Something about the properties of water, and also then we want to talk about time-dependent trends in water parameters. So this aquaponics system that we have here, it's tilapia based, so that's the nutrient source, and then we have plants to consume the nutrients. So let's talk a little bit about the options we have to test water chemistry by simple means. So the first thing we'll try out is basic water test kit for fish tanks. So we can test pH, carbonate, hardness, iron, nitrite and nitrate. This is water straight out of one of the grow beds, and everything is interconnected in this system. But as you can perhaps see on the pictures here, it's not totally clear. It has some tint to it, so it's a bit yellowish. The yellow color is nothing to worry about. It's it's like lake water, water from a river. It can have a slight tint, and it's often the useful bacteria that stains the water a bit. We're gonna start out with nitrate, just because it takes a bit longer, so it can just sit and wait for the other tests. So I guess we can just skip hardness. I think it's near zero. And just quickly let us interpret the results and start with pH. So 6.3, that's perfect for, like, yeah, the plants living out there. Is a bit low maybe for the fish, but they will be fine. So nitrite, that one could never be low enough. And let's have a quick look at the color scale here. So we're still in the green area. We use rainwater quite a lot for this fish farm, and yeah, there's some tricky things about rainwater actually. So first one is that rainwater is slightly acidic, and pH is quite a lot below 7, and even if it's close to 7, the buffering capacity of it's low, so you need to add ions just to keep it stable. So we use let's see if I can show you. This is something called fodder lime, and it's used usually for cattle and such. So yeah, if the water is good except for the pH, then it's no need actually to replace the water, so just add some buffer. I would love to add some salt to it all, but yeah, it could be tricky because the plants do not really appreciate salt. But yeah, the fish would, I would assume. So salt is good for keeping fungi and bacteria and viruses down. We basically have two water sources here. So one is rainwater, and the other one is public water. So yeah, let's talk a little bit about water purity. and cations and stuff. So yeah, this lab is a mess full of cables and wires, as you see. So some important things that we have, it's the multimeter and the battery and cables, of course. And then let me just introduce the water samples. So as you might reckon already, the one to the left looks most impure. That's fish tank water from the garage. So let's just keep notes here. Fish tank. Next one, it's tap water from a public source, tap. And then in the last one, it's rainwater. This pen is no good. So we wired it up like this. So the red positive cable is going straight into the multimeter, right? And the black one, the negative one, will connect to one of these yellow wires, and here we put together a small sort of probe here. So from that point the current needs to travel in the water in the sample, and then it comes up in another yellow wire, and that one goes into the measurement device. So the first sample that we do now, that's the rainwater, and we're measuring amps right now, so we have to calculate the conductivity later. Okay, so that one, it's 0.9 microamps. So we put the water sample in a sort of purity order, with rainwater first, then tap, and then fish tank water. And the reason for doing that is so that we don't have to clean so much, because the ions will increase in the upcoming samples, and then we don't bother about cleaning. Okay, we're on to the next sample then. So be careful not to let these wires connect, because it will blow the fuse in the instrument. So remove this one for now. So let's put the cable on the battery again, and let's see what happens. So I guess we're out of range. So this one is 5.38, let's say. So the rain and the tap water are usually mixed in here in the garage. So now, as you see, we can conduct a lot of more amps. So it's now 13 point something. Yeah, 13.75. Let's put the clamps there. I'm kind of curious if we can affect the electrical properties by adding lime. This is crushed lime. We're still at 13.85 sort of. Let's try with any amount. It's 1 tablespoon, 1.5 tablespoons, I guess, and then mix it properly. No, not much is happening. Perhaps a slight increase, and I think this will continue to increase because the iron, it takes time to dissolve the lime. We could add salt to it just to see what happens. So let's get salt. found it. And we're at 14.1 or 2. And you didn't see that, but now we got out of range again. So let's turn it a bit. So let's see. So salt impacts the conductivity or the amp, in this case, much more than the lime did. And now what happens? It's the salt that's being dissolved out of range again. So yeah, another thing that we can try is to use the, as you see, we have also an ohm setting here to measure resistance, and we can do that, but then we have to sort of disconnect the battery and rewire this stuff. So now we have to change the red lead connection like that, and then turn it to fresh water. Is usually highly resistive, so you can start at the highest setting with 20 mega ohm. And let's connect the wires also. So now it's just a matter of attaching it, one of the cables, the black one, from the multimeter to the instrument cable goes into the water, and we'll do the same with the red one, like so. So this table is from the municipality water plant. Turbidity might be interesting, and the pH definitely. Conductivity, as we tried out ourselves with the multimeter, it's between 18 and 56. This is interesting, nitrite and nitrate. So nitrite at least is very low, and especially if you use a combination between tap and rainwater, you can really make it close to zero. And yeah, so it's interesting to have a look at these tables, and in Sweden they are available for most public water sources. This that you see right here, it's basically the nitrogen cycle for an aquaponics system, or any fish tank for that matter. So first we have poop, right? Fish poop. That creates ammonia. In this part, if we have high pH, then this nitrogen compound will be more of a toxic substance. This one. At low pH, it's not as toxic. Then we have these fellows are helpful bacteria that breaks the ammonia down to nitrite, and as you see, it's also poisonous. Yeah, and then we have other friendly bacteria, these nitrobacter, that breaks the nitrite down to nitrate. Nitrate is not as toxic as nitrite, and it can also be consumed by the plants. So there's other sources for nitrogen than just fish poop. So yeah, decaying plants that cause nitrogen and ammonia to go up, and also nitrate and nitrite. Uneaten food, fish poop, of course, like mentioned. If there's dead fish lying around, that will also cause a nitrite elevation, and then dirty canister filters. So here the brown stuff is decaying organic matter, which would produce some nitrite. This filter is full of filter media that are used to grow the beneficial bacteria. Also, let's see if we can find any grow media. These expanded clay pellets are also a good place. It has a large surface area to grow the bacteria on. Nitrite poisoning and suffocation, that's one of the most important health issues for fish, especially in new tanks where the bacteria has not yet colonized filters and gravel substrates and such. So if we can understand that a bit better, we have a better chance of keeping our fish nice and happy. So the thing with nitrite is that the fish consumes it by staying in the water and inhaling water. What happens then is that the fish blood, it's usually transporting oxygen, but when you have too much nitrite, will expose the fish to nitrite poisoning, and as the oxygen levels go down in the fish blood, you also fish will suffocate and die. So an aim for nitrite contents in the fish tank water, an aim for is 0 milligrams per liter. So speaking of nutrients, nitrogen or nitrate is one of the things that plant needs to thrive in our systems. We also need to have phosphorus and potassium. Also minor micronutrients like copper needs to be present, and also iron. The plant itself consumes carbon dioxide and gives away oxygen. pH usually go down a bit with time, and then here we have a water change, then it goes back up again. Could be that we add some lime. Then we have CO2. Let's do that one together. It's sort of in the opposite direction. So if we start at the level, with time it will increase, and then we have the water change, and it drops off again. So the explanation for the pH drop with time should be then that the fish breathe and creates carbon dioxide, that it's solvable in water, and it also lowers the pH then. Nutrients such as iron and phosphorus, potassium are being consumed with time by the plants, and perhaps we add some fertilizer and it goes back up again, and then starts to decline. Nitrite, usually at this stage it's sort of balanced and it doesn't seem to increase, but then if a fish dies without you knowing it, or if something happens to the filters, like you have a power out, and then nitrite goes up. It could be solved either by waiting and letting the bacteria recolonize the filter, or you change a bit of water, or both. And I guess everything is affected by this water change that we have during this period. So pH goes up, and the carbon dioxide goes down. If we have fertilizer in the system, they will go down from the water change, of course. Then nitrite will go down also. And nitrate, it sort of follows the trend of the nitrite. So as these are interconnected and one turns into the other, you might have a time lag in the trends then. So by doing water analysis, you get to know your system and the trends, and after a while you get better at it to know what to look for, and then it's easier, and you can also perhaps cut back on the lab time. And so we need to know about optimal values. We do all this testing and stuff to help create a better environment for the fish and the plants. So in this aquaponics system that we have, it's tilapia mainly, or only as a fish species, and then there's usually some peppers and chilies, basil and stuff. So these are the values we aim for here. So temperature, it's close to 30 degrees. pH somewhere between 6.5 and 7.5. Nitrite as little as possible, of course. Nitrate sort of lower than 150 200 ppms. Dissolved oxygen is supposed to be over 5 ppm, so we have to get a water test for that also. If you're a basil plant, you kind of like to have your feet in quite warm water, but else maybe plants would rather do like 20 degrees. And pH wise, sort of go a bit lower maybe. So let's put plants here. Plants. Nitrate could be higher, I think. And oxygen is good for the roots, so that one should perhaps be 5 also or above. Fish on the other hand, so fish would love to be in this sort of region and this region, and yeah, maybe even higher on the pH. So this numbers here are sort of what works for both fish and plants. To keep oxygen levels high, we have bubblers in the tanks, and then we also keep water circulating to stir up the water surface. This green unit is what produced the aeration in this system, so it has a manifold here, so it can run I think it's 12 simultaneous bubblers. So yeah, I really appreciate that you tuned in today, so be sure to press the like button, or yeah, even to subscribe if you like, or comment. It's always nice to have some interaction, and see you next time.